Today we're going to be looking at how to graph systems of equations. So sometimes they're going to make us graph our own linear equations to discover how many solutions the system has. So let's review about the equation for a linear line. We have y equals mx plus b. M represents the slope. And we've talked about slope in the ratio of rise over run. B represents the y-intercept. And the y-intercept is when x equals 0. So let's look at how we can graph these. Our first one is y equals negative 2x plus 6. So negative 2 would represent our slope and 6 would represent our y-intercept. If we looked at our slope of negative 2, we could put negative 2 over 1. So this means that we would go down 2 units and to the right 1 unit. So we're going to start at our y-intercept, which is positive 6. This is our origin, 0, 0, so we're going to go up 6 units. 1, 2, 3, 4, 5, 6. And now we're going to apply our slope. So we can't go up, but we can go down. So we're going to go down 2 units, 1, 2, and then to the right 1 unit to make that negative slope. Down 2, 1, 2, and to the right 1, down 2, to the right 1. You need about 3 points to create a nice solid line. We have 4 points here, and so we're going to take our ruler and we're going to connect our dots, putting arrowheads at the end to represent a line. Our next system we're going to graph is 2x plus 2. So our slope is a positive 2. So we can put 2 over 1, which means that we'd be going up 2 and right 1 unit. Our y-intercept is at positive 2, so it's where we're going to start at. So here's 0, 0. We're going to go up 2, and now we're going to apply our slope. So we can go forward in this one. So we're going to go up 2, 1, 2, to the right 1 unit. Up 2, to the right 1 unit. Down 2, and now we'd have to go to the left. So the reason why I went down is because I want to get 1 more point to graph this line. So if I go down 2, I have to go left 1, so then I would have a negative divided by a negative, which would create my positive. I have 4 points, and I'm going to bring my ruler in, and I'm going to connect my dots. Put my arrowheads to make my line. So my 2 linear systems intersect at this point. How many times they intersect tells us how many solutions there will be. So these 2 systems intersect once, so therefore there would be 1 solution to this system. Let's take a look at another one. Here we have 2/3 x plus 3, and we have 2/3 x minus 2. So our slope is already in fractional form, so we have 2/3, which means that we're going to go up 2 and to the right 3 units. Let's start at our y-intercept, which is positive 3. So we're going to be at 0, 0, go up 3. 1, 2, 3. And now we're going to apply the slope. So our slope is rise 2, 1, 2, and then we're going to run 3 to the right. 1, 2, 3. There's no more ways I can move up, so I now have to go in the opposite direction. So then I'm going to go down 2, 1, 2. I'm negative, so therefore I need to go to the left to make it positive. 1, 2, 3. I could go down 2 more, but I don't have any more graph to move to the right. So this one I can only have my 3 points. So I'm going to connect my dots, to create my line. Okay, my next system, I have the same slope, rise 2, run 3, and my y-intercept is at -2. So I'm going to start at -2. If this is 0, I need to go down 2 and plot my point. My slope is going to go up 2, 1, 2, and I'm going to run 3, 1, 2, 3, and that is to the right. I can go up 2, 1, 2, and then over 3. It's going to put me a little over here, so, and if I try going down, I don't have enough, so I have to make my best guess of this with just the 2 points that I'm allowed to graph. So I'm going to take my ruler, and I'm going to connect my points. And as I can see, these two systems do not intersect. These systems are called parallel lines. So if they do not intersect, that means that there is no solution to this system. So we could have one solution, they intersect once, or if they're parallel, they don't intersect, so that would lead to no solution. Let's check out another one. Here we have -2x plus 2, and we have -2x plus 2. So let's check out what our slope is. So I can put this over 1. So I'm going to have -2 over 1 means I need to go down 2 and to the right 1 unit. My y-intercept is +2. So here's my origin, 1, 2, plot it, and now I'm going to apply my slope. So I'm going to go down 2, 1, 2, and to the right 1. Down 2, to the right 1, down 2, to the right 1. Or I could go up 2, and therefore I'd have to go left 1 to keep it negative. I have my points, and now I'm going to connect them. Now we're going to look at our second system. We have -2x plus 2. So our -2 is the same slope, down 2 over 1. Our y-intercept is also at +2. So here's 0, 0. We're going to go up 2, plot our point, then down 2 over 1, down 2 over 1, down 2 over 1, or up 2 and then to the left 1. And as you can see, these are the same points that were on our first system. So if we connect it, we get the exact same line. So our two lines are on top of each other. So every single point is intersecting one another. When this happens, we could say that the number of solutions is infinitely many, meaning that all of the points intersect the same point that is on the two functions. So we have infinitely many solutions. These are your three types of solutions you can have. Infinitely many, when you have the same graph, because all the points are intersecting each other. You could have no solution. This is when your lines are parallel and they do not intersect. Or you can have one solution when your two solutions intersect at exactly one point.